Let's talk about standard deviation, mean absolute deviation, and z-scores. These terms all deal with data sets. Before we begin, take a look at this key. It will help you to understand the formulas we will be showing you later.
Go.
In order to understand standard deviation and mean absolute deviation, you need to be familiar with what mean is. Remember that the mean is the average of the dataset and is calculated by adding all the values in the dataset together and dividing by the total number of values. Let's calculate the mean of a dataset with the values 39, 44, 50, 56, and 61. When you add these values together, you get a sum of 250. Then divide by the number of values, 5, to get a mean of 50. Now let's talk about how to find the standard deviation of the data set. Standard deviation is the variance, or measure of the spread of data samples from the mean. The closer in value the data samples are, the smaller the standard deviation will be, and vice versa. Standard deviation is calculated by using that formula. We'll use the same data set we used earlier. The first step is to subtract the mean, which is 50, from each of the values and then square each difference. 39 minus 50 is 11 squared, which is 120, or negative 11 squared, which is 121. Negative 11 squared, which is 121. 44 minus 50 is negative 6 squared, which is 36. 50 minus 50 is 0, which squared is still 0. 56 minus 50 is 6. 6 squared is 36. And 61 minus 50 is 11 squared, which is 121. Now add all those values together. 121 plus 36 plus 121 plus 36 should give you a sum of 314. Now we divide the number of data samples, which is 5, by 300, or from 314. You should get 62.8. When we take the square root of 62.8, we get 7.9. So the standard deviation of the data set is 7.9. Let's use the same data set to take a look at mean absolute deviation. Mean absolute deviation is the average distance of all the elements in the data set from the mean. Mean absolute deviation is calculated using this formula. The first step is to subtract the mean from each of the data samples and take the absolute value of the differences. So the absolute value of 39 minus 50 is 11. The absolute value of 44 minus 50 is 6. The absolute value of 50 minus 50 is 0. The absolute value of 56 minus 50 is 6. And the absolute value of 61 minus 50 is 11. Next, add all of these values together. You should get 34. Then divide by the number of values, which is 5. 34 divided by 5 is 6.8. So the mean absolute deviation is 6.8. To understand z-scores, you must be familiar with a bell curve. The bell curve is perfectly symmetrical and is divided into 6 sections. In the center of the bell curve is the mean of the data set. 68% of the data falls within one standard deviation of the mean, and 95% falls within 2. One z-score is equal to one standard deviation. At the mean, the z-score is 0. To calculate the z-score, use the formula z equals x minus mu over over sigma. In some problems, your z-score will be a decimal. When this is the case, you will need to refer to a z-table. The z-table will always be provided to you if needed. Let's do a multiple choice question like what you might see on the SOL. We will use the same data set as before. How many z-scores from this data set have a value of 0.3 or greater? We already know that the mean is 50 and the standard deviation is 7.9, so simply plug each data sample into the equation. 39 minus 50 divided by 7.9 yields a negative 1.39. 44 minus 50 divided by 7.9 equals negative 0.76. 50 minus 50 divided by 7.9 equals 0. 56 minus 50 divided by 7.9 equals 0.76. 61 minus 50 divided by 7.9 is 1.39. 0.76 and 1.39 are larger than 0.3, so the answer is 2 z-scores, which is letter B. We hope this was helpful to you.